Okay, so it's fixed. Units here. We have iPhone 6s. So if I plug the phone to the power, so let's touch with the new screen. Doesn't show nothing on the screen, and the phone is taken. So let's plug it to the. Oh yeah, some spots is getting hot. I set up about like a 4 volt, and when I plug it, it's taking about 300 milliamp. So we got a shirt somewhere. Or a bad IC. Just we need to find out where. That's 300 milliamp is before pushing the power button. I mean, just you plug the DC power supply, it's showing you the 300. There is a little signs of the water damage, but the board, it doesn't look that bad. So let's go on the microscope. Now start looking for any burning or corrosion. Some here. A little bit here. Yeah, the board, it doesn't look bad. Right. So still can't see nothing. That looks. Next, it's gonna be the thermal imaging camera. Let me show you my new setup. So this is a Flare 1 Pro. So you can get this cord, USB-C male to female. So that time you don't have to be holding the phone. You can put it in the side. That's the board. Alright, watch this spot here. We make everything dim, so we're going to turn on the power supply. Watch closely, right over there. You see that's one is getting warm little by little. So next we're going to use the alcohol, see if we can find which exactly part is getting warm. So if we measure the resistance around some capacitor around this chip, on this capacitor is a 23 ohm. That's very low. And so this is another board, just to be sure what. So we measure the same. And we have like by kilo ohm over there. We almost 2 kilo ohm. And that line is a VCC main, so it's a battery line. Let's explain the. So we need to find which capacitor, this one, or these two here. That's causing even this one. That's causing the surge. So let's use the thermal imaging camera again. Yeah, the alignment in the thermal imaging camera is not perfectly, like sometimes it shows the side. So right here, you know what, it looks like the capacitor that I test, that's the one is causing the. So the camera show it here, but is real is here. So like when I cover it, I can tell which one is. So this is another way to use this camera. So here, yep, right here. Kinda is this capacitor here. That's the one is. Yeah. Watch this capacitor here. Let's remove that one. The shirt still exists. So I did remove the two capacitors. This was showing me getting hot. But it's still like the resistance to the ground is still low. It's still 24. And that spot's still getting hot. Even the capacitor is gone. So I'm gonna remove the CPU shell. Look at this. Oh yeah. This is the older side, so basically the heat from the bottom side, the other side of the board, it wasn't from that capacitor. Capacitor was fine. Yep, that's a backlight diode. That's the diode over there. And you know what? Let's confirm that's what is the heat come from.
Own vehicle.
All right.
Turn this light off.
Yep.
All right. See you later.
Let's see. So watch the chip. So let's remove it. Yeah, basically the thermal imaging camera, it was giving us a good idea where to look, but if it's in the top or in the bottom, that's going to be our work to find out. Gonna remove the ender fill. diode from here. Oh, it's going to be short inside the chip. Let's remove the remove the diode or remove the chip. Let's do the chip. Before in this diode, it was showing like very low. Look, to explain to you, the diode is connected to this capacitor, and this one here is connected to here. So it's kind of hard for me to test from here to here. I'm just going to test from here to here. So at the first, it was a very low resistance, about like 10 ohm or something like that. So I tested from here to here, but now there is no shortage at all. So let's test the other where it was the two capacitor in the VCC main. Nothing. So basically is the chip. Still could be the diode as well, need to be changed. But let's put the chip. And see how it's going. I don't think I do have any new chip for this one, so I'm just going to use another chip. more time because be sure all the pads is the same size. Alright, must be good now. Yeah, the resistance to the ground now is 1.4, 1.5. It's because the board 1.7 because the board is still warm. That's why it's still going up. So basically, that low partial surge is gone now. So let's connect it to the DC and see if it's. The phone is connected to the DC power supply. And you can see 3.9 volt and 0 amp. So the surge is gone. Let's spot it quick. You want to test it with the original screen. Burn it myself. Wow, it's very hot. Yeah, you see that white square? That's the chip mark on my finger. Yeah, I burned myself. Yeah, that chip that I replace it is burned because I test the phone with the old screen, and so I did remove the chip, and I did remove the diode next to it. So I want to test the phone before I put the chip back, another one. So there is no surge. Push the power button. Phone is booting. the Apple logo is showing over there. Just waiting for the home screen to show. Yeah, I can see the passcode. So the phone is booting, just need the backlight. So let's put the chip and put the diode back, and we'll see if we get the backlight to work. So I changed the diode, and I put another chip from iPhone 6 Plus this time, because I don't have the 6S anymore. But it's the same chip, it will work. And the same thing, I changed the diode as well, the backlight diode. I push the power button. The Apple logo is there. The brightness is okay. And I guess the phone is fixed. Wait till it show the home screen. We test the touch screen. And I will transfer the stuff, the camera, speaker, and other stuff from old screen. And plus I put the CPU shield on it, put it together. Then we call the customer to come pick up their phone. Yeah, the touch screen work. Thank you for watching. Please subscribe if you want to see more videos in the future about repairing